All right, this video is for the lesson 4.3 homework. This is properties of logs. How many are on this one? 17. All right. So number one, what do we got?
The product rule for logarithms states that log base b and in parentheses mn equals blank.
Okay, so this may be one where I need to run you guys some copies.
I think it.
Because I've got tables of all of that stuff, all the rules. It's addition. Well, I thought I had a table that had all the rules. Yeah. Okay. I can run y'all a copy of this. So it would be, the base would stay the same, but you could split it. You could do log base b of m plus log base b of n.
Teachers, if you have...
I've already done it, so. All right.
Please post your attendance. Thank you.
Number two, what do we got?
The quotient rule for logarithms states that log base b parentheses m over n equals blank.
Okay, so this is the product rule. This is the quotient rule. So this one is subtraction. So you could do log base b of m minus log base b of n. We use this when we're trying to simplify these things. Okay, number three.
The power rule for logarithms states that log base b times m to the power of p equals blank.
M to the power, like it's in here, like that?
Well, there's no parentheses. It's just b and then m. And
Okay. So what happens is we don't do exponents here. If you've got an exponent on what you're taking the log of, it becomes a coefficient. Okay. Number four.
The change of base property for logarithms allows a logarithm with base b to be written in terms of a new base a. Introducing base a, the property states that log base b m equals, and then it's like 3 lines.
Okay, let me look at it. It should be like this. Okay? So if the new base is a, I should be able to write log of base a, and then this piece stays the same, over log base a, and then you use the base here. There's not a really good way to explain how that works. So new base takes this place, this stays in the same place, and then this kind of switches around. That's one just to write down an example to kind of see how everything moves. Is that right? Was that the right answer? Okay. All right, number 5.
Use properties of logarithms to expand the logarithmic expression as much as possible. Where possible, evaluate logarithmic expressions without using a calculator.
Okay.
It says log base of 6 of 5 times 2.
Like this.
Yeah.
So if it says expand, right?
Yes, ma'am.
Okay. So we would have log 6 of 5 plus log 6 of 2. Or I can show you. All right, 6.
It's the same type of question, but it's log base of 10 to 10 over y.
10 over y. Okay. So this would be log 10 of 10 minus log base 10 of y. This, so think of this like an exponent, right? If we write this as an exponential, log base 10 of 10 would be 10 to the x equals 10. And that would equal 1, right? So log base 10 of 10 should be equal to 1. Is it multiple choice, or do you have to type these in?
You have to type them in.
I believe that is right. So let me check. Your eyeballs will catch kind of wonky stuff like that. Always kind of think of it in terms of an exponent. If it's something you can simplify real quick, real easy. Hopefully we'll see some of these so I can show you what else you can do that way. All right, 7.
Sorry. Log base of 2 of 8 over y.
Log base of 2 of 8 over y.
Yes, ma'am.
So that one should just be
Log base of 2 minus 8.
of 8.
Of 8.
But this may be one that we can simplify. This piece right here. So this would be 2 to the x equals 8. This logarithm, written in exponential form. 8 can be written by a base of 2. So that's something you always check. Can I write it as a base of 2? Can I multiply 2's enough times to get an 8? So we know 2 times 2, that's 2 squared, is just 4.
Would it just be 3 minus log?
Well, so yeah, this is equal to, so again, how you would do it, you would write 8 as a base of 2 cubed, and then you can set the exponents equal to each other, just because sometimes they're a little bit more complex than that. But yeah, this would be a 3. So log base 2 of 8 equals 3. So we would have 3 minus log base 2 of y. Algebra 2, did y'all do logarithms, or was it pre-cal?
Pre-cal.
Pre-cal, okay.
It was the
I
first
think-
thing we did in
I
pre-cal.
think we did some.
We did a little bit probably towards the end of the year.
Because I know I taught it a little bit in algebraic reasoning. Because we had to do inverses, and it's the inverse of an exponential.
Spent the whole the first 6 weeks in pre-cal on log,
Doing logs.
and then the very end to put a graph, like,
Yeah. Graphs and transformations and all that fun stuff. All right, number 8, what do we got?
Log base of y of x to power 2.
X to the power 2, like this?
Yes.
Okay. So exponent becomes a coefficient. And that should be it. There shouldn't be anything else that simplifies there.
We threw 2 in on the next one.
Okay, I'll grab a different sheet so I got plenty of room here. Okay. 9.
Log base b to x to the 6th y. It's like all in one parenthesis.
Like this.
Yeah.
Okay. So first thing I'm going to do, so there's multiplication here. So I'm going to split it. I'm going to do log base b of x to the 6th plus log base b of y.
Would you take out the 6 and put it in front?
So after I split it, then I would make it the coefficient. If I do it before, it would attach to this one, and it's not attached to this piece. So far, not too bad. All right. 10?
Log base b to x squared y over z squared.
Okay. Split it before you do anything else. I'm going to split the division first. Okay? So I would have log of base b x squared y minus log base b z squared. Then I split this. So this is addition. So it would be log base b of x squared plus log base b of y minus, and if you want to go ahead and make it a coefficient, I try to do everything at the same time, all the steps at the same time. And then make your exponents coefficients. So 2 log b of x log b of y minus 2 log b of z. Okay. Eleven.
It's the same type of question where it says n, like in x plus in 17.
Oh, ln.
Oh,
Okay.
it's the same thing.
ln x. What was the rest of it?
Plus ln 17.
Okay, so that's the natural log. Give me a second here. It just went, see, for those, that's one of those things that still to this day I have to constantly look at. Okay, ln of x plus ln of 7. Okay. Yeah, same rules. My brain just doesn't ever want to do it. Oh, that was 17 or 7?
17.
17, okay. So it's just natural log 17x. You just smush them back together.
What it, I'm not sure if you've already explained this before, but what exactly is natural log?
So it's when you use Euler's number.
Euler's number.
So it's when you have a base e. Log of base e of x, we would write as the natural log of x.
All right.
It's when Euler's number is the base. Okay, 12.
Now it says condense the logs back together.
Okay.
And then it says log, there's no base, but and then
Okay.
it's 4x plus 7 minus log to x.
Minus log of what?
X.
X. Okay. If there's no base given, it's an assumed base 10.
Base
Just
10.
base 10. Just so you know that that's what it is. So in this one, this would be division.
So it's
So whatever comes first goes on top, and then the second piece goes on bottom. So order matters in division and subtraction with any type of operations. Right. 13.
log y plus 7 log z.
Plus,
It just says, I guess, times. There's just no space or nothing in between.
ooh. So it's log.
Frozen.
Okay, y plus 7 log z. Written like that?
Yeah.
Okay, that's what it is. And that's why we use the parentheses. That's exactly why we use the parentheses. So what we have, this is log z to the 7th. And then since it's addition, it's log y z to the 7th. It's multiplication when you combine them back together.
So it's going to be base 10.
Yeah, assumed base 10 on that one.
Z to the 7th.
Mm-hmm.
Okay.
Why parentheses are important. Is it making you put the base in when you type those?
Yes.
Okay. You haven't had to put them on the base 10 ones?
I put base 10 and they still got it right.
It's equivalent. We just, if it's a base 10, it's assumed. You just don't write anything there. If there's nothing written there, you assume that it's a base 10. All right, 14.
1/8 ln y, no parentheses,
Okay.
plus ln z, no parentheses.
Oh, this one will be interesting. So this is ln y to the 8th plus ln of z, which would be division. So y, oh wait, it's addition, right?
Yes.
Addition here?
Yep.
So it's multiplication, sorry. Y to the 8th times z. That's what it should be. That 8th has got me, because we typically don't do fractions.
Oh, that was correct, so.
It is?
Yep.
Okay.
So I'll take it.
And I don't know, that may be something that has changed since I did all of this full time. Our calculators couldn't do what like these TI Inspires can do now. Like all we could type in were base 10 logs. That's it. Everything else was by hand, and you were converting it and changing bases, and so that may be part of it. All right, 15.
2 ln, no parentheses, x, minus 6 ln y.
Okay.
No parentheses. But that, you just move it back over to the exponents, right? And it's-
Yeah, so this becomes a squared, this becomes a 6th, and then since it's subtraction, it would be x squared over y to the 6th. Okay.
Use the change of base property to rewrite the given expression in terms of natural logarithms or common logarithms.
Okay,
It
so
says do not evaluate.
change a base.
Yeah.
Okay, so here's that little template that we use. This would be 16 then. Okay, so what do we got?
Log base 19 to 11.
Like this?
Yeah, no parentheses though. I don't
And
know.
then what does it want us to change the base to?
It just says do not evaluate. It just says use change of base properties to rewrite given expression
I
in
just
terms of
assume it's
natural logarithms. So ln
It wants us to write it as a natural logarithm?
or common.
Are you
we have two questions left.
I'm going over there.
Okay.
When you finish this, can you leave?
Yeah, absolutely, absolutely. Okay, so let me look. It's wanting. Back when the calculator only did base 10, you would always change things to a base of 10. And so if we use this formula for that, again, you can write the 10 here, but you should just be able to do log, and then, so if we look, the parentheses goes on top, and then the bottom would be log of 19. You should be able to write it without even the base, I think. and assumed base 10. When the calculators only did base 10, you had to use that formula every time to do these, because that was the only way to calculate and get an accurate answer.
Now it's saying to evaluate. It says type an integer or decimal. Do not round until final answer. Then round to four decimal places.
Okay. So again, when we had to do these in a calculator that wouldn't do this, you would do, and again, we can do so much more now, but you would have to do each piece separately. So, and again, see, I can type the bases in now, but you would do each piece separately, and then you would divide it. 1.04139 divided by 1.27875. Now I can put a fraction in a calculator, which again 20 years ago was unheard of. Probably not. There were probably calculators out there that did it.
But they were like
Nothing that we could get our hands on. What place does it want you to round that to?
Fourth. It was
A
8144.
So 4 numbers.
Yeah.
0.8144. Let's see. And yeah, that's got the same there. All right, 17. Last one.
Use the. I mean, it's the same.
Okay.
But log base 13 to 88.5.
This is 88.5.
Yeah.
So we would have log of 88.5 over log of 13. And then again, once you get it to that point, but I'll show you this too. These calculators, you can just do log 13, 88.5, and it would give you the same thing as the change of base formula. Okay. Again, we've got calculators now that do this. I will say this, so I know like Ethan's math classes, 7, 4, 7, 8, they do not allow the Inspire. And I still believe on a TI-84, you can only do base 10. So, and that may be the rationale behind that. We have Inspires, but most college classes, it's an 84. And that's all of them, right?